This video looks at chapter 12.4, exercises in your book on page 356. And we're going to start with number 3, which says change 8 plus 6j to polar form. Note that it is currently in rectangular form where a equals 8. Sometimes we call that x is 8. A or x, it doesn't really matter. B is equal to 6. B is always the imaginary part with the j, or sometimes we call that y is 6. To figure out how to write rectangular form into polar form, you first have to go back to your study of vectors, and we have to find r. So we know that r squared is equal to x squared plus y squared, or a squared plus b squared. It's the Pythagorean theorem. Either one is fine. So we have r squared equals the square, let's erase that. We don't want the square root. So r squared equals 8 squared plus 6 squared, which equals 100. If r squared equals 100, then r equals 10. So we found our first part. To write this rectangular number in polar form, you find r and then you find your angle. To find the angle, we use the inverse tan function, and we always do y over x. So we have 6 over 8. Use your calculator, and you would get 36.869897, and we round that to 36.9 to the nearest tenth. Now we have theta and we have r. The final step that you take is to just write 8 plus 6j as, list your r, 10. Then in parentheses you put cosine of whatever your angle is, 36.9 degrees plus j times the sine of 36.9 degrees. You'll see in some books they write that like this, 10 cis 36.9 degrees. That's so much easier than all the long drawn out one, but your book uses the long drawn out form, so I will too. That's all you do. That is now in polar form. So how did we do it again? We found r, then we used the inverse tan to find theta. Remember up here, just to keep this in mind, so you know, we got an angle of 36.9. Both x and y were positive. So remember your study here from vectors. If x is 8 and y is 6, it would be somewhere in here. So 36.9 for theta does make sense. But sometimes your x and y will be negative. We have to be careful with that. Okay, let's try problem number 5. Problem number 5 states that we are to take 30 minus 40j and write in polar form. Okay. Convert to polar form. So x equals 30. Y equals negative 40, because the y is always with j, the imaginary part, and the x is your real part. That's what makes the rectangular form, is your real plus your imaginary part. So let's find our r. R is going to be equal to the square root of 30 squared plus negative 40 squared, which is equal to 900 plus 1600, and if you take the square root of that, you're going to get 50. So we have r equals 50. That's the first part that we need. Now let's find theta. Remember, that would be your magnitude of your vector. So theta is going to equal to the inverse tan of y over x. Now, we don't use the negative here. We just take 40 over 30. Don't use the negative with the y. And when you do that, you get an an angle of 53.1301, which is 53.1 degrees. Now, remember, on your Cartesian plane, your x was 30, so it was positive here, and then your y was a negative. So we went over 30 and down 40. Your vector is in your fourth quadrant. So even though we found an angle of 53.1 degrees, that represents this reference angle. So to find out what theta is, we're going to have to take 360 degrees minus the 53.1 degrees. And that will give us 306.9 degrees. So when we write our final answer, we take r, which is 50, times the cosine of 306.9 degrees plus j times the sine of 306.9 degrees. And that's it. Simple as it gets. Let's try another one. Just go a little bit thicker with our lines here. Let's try number 7. Number 7 shows that 3.00 j minus 2.00. The trick to this one is they're throwing you off because if you notice what they're listing first, they're putting the j first. So you don't want to fall for this. Remember that your x is going to be your real part. So it's going to be the negative 2.00. Your y is always with the j part, so your y is 3.00. So we do the same thing that we did before, and we take r is equal to the square root of negative 2.00 squared plus 3.00 squared, which is going to give us 3.6055. which equals 3.61, and we go to 3.61 because they gave us the original numbers to the hundredths place. So r is equal to 3.61. Now let's find theta. Theta is going to be equal to the inverse tan of y over x, 3 over 2, which equals 56.3 degrees. Now again, we have to check. If we have our Cartesian plane and our x is a negative 2, we would go this way, and y is 3, so our angle is going to be in the second quadrant. So this 56 degrees is actually the reference angle. So we have to figure out this angle. So we would take 180 degrees minus the 56.3 degrees, and that is going to give us 123.7 degrees. So our final answer is, you list r first, 3.61, and in parentheses, cosine of your angle theta, 123.7 degrees, plus j times the sine of 123.7 degrees. Seems easy, doesn't it? Okay, let's move on here to number 15. And I'm going to try to get the line a little bit bigger, I think. So let's try 15. 15, you're just given negative 3. You're told to write that in polar form. Now, what you have to be aware is that there is no imaginary part. So your x is negative 3, and your y is 0. Now, if you think about that on your Cartesian plane, if your x is negative 3, it would be over here. We're not going up or down. So remember that we're looking at this angle, 180 degrees. Okay, so let's do the same thing we always do. We take our r is equal to the square root of negative 3 squared plus 0 squared, which equals the square root of 9, which equals 3. But be careful here, because if you do your tan of 0 over 3, you're going to get 0 for your angle, and that is not correct. That's not correct. These, when you're only given one part, the real or the imaginary part, it's not going to work out to do this. Okay, you have to think it through. So our answer here, we know that because we went negative 3 and up 0, we're at 180 degrees. we just stop there and put our answer as 3 times the cosine of 180 degrees plus j times the sine of 180 degrees. So those are just a little bit different. I'll show you another one here just like that. It's number 17 and it lists 9j. So you don't have an x because there's no real part. So your x, let's redo that, that's just a mess. So your x is 0. Your y is, excuse me, 9. So on your Cartesian plane, if you think about that, you're going over 0 and up 9. So do you see that we're talking about this angle, which is 90 degrees? So let's find our r. R will equal the square root of 0 squared plus 9 squared is going to equal 9. We don't have to do anything else because we were only given one part. So our answer becomes r9 times the cosine of 90 degrees plus j times the sine of 90 degrees. And that is your final answer. Okay, I'm going to quit here and pick up at in problem number 19 in the second video, where we will change from complex numbers to rectangular form.